Ladies and gentlemen, as you just heard from City, it is 3 p.m. 3 p.m. in the Netherlands. Today, talking to all the world about a topic that fascinates us. One of the biggest markets of photonics technology, robots. Let's do business together. Francesca, great job assembling this fantastic supply chain. Yes, we had several epic meetings looking at what sensors could do for robotics. Some great companies have come forward to say what has to happen over the next 3 years. But we can do so much more this year. Seeing from the perspective of the robotic industry, it's all about precision and speed. Robots often need to observe things in motion and react with ultra-fast photonic speed. I remember walking around precision tool exhibitions and thinking, suppose that robot arm from ABB was equipped with 3D sensing, or what could Japanese giant KUKA do for the automotive sector if smart hyperspectral cameras were included? In our meeting on the 1st of February, why don't we ask DEMCON about their vision needs in robotics and then match them with the cameras of Roboception. Look at this. Stereo cameras remind me of one of the most glorious sci-fi movies of the 80s. Check out my VIP list. Epson or Yaskaba in Semicon, Transcenterics in medical, Boston Dynamics in security, or Amazon in logistics. So let's connect with robotic companies on February 1st at 3 p.m. Sign up for the Zoom room or watch live or later at the Epic YouTube channel. I was acting at the end of the video. I am never tired. I don't sleep. I only live out of photonics. It was really a lot of work. A lot of work from Dr. Francesca Moglia to put together such a list of companies. Let me remind you, today we have in the room Epson, KUKA, ABB, and Intel looking for collaborations. This is a great opportunity. The next 2 hours are going to be epic. As epic is the growth of this association, we are very close now to being 700 members. I need to buy another sticker to put here. Very close, getting there. And this only is a result of how much you like us. Thank you very much for all the constant support you keep giving us. I'm here on behalf of a fantastic team of experts from the medical to the integrated photonics, with people in the photonics research market, people on the marketing side, and all we do for you is everything that is legal. And if it's not legal, ask us and we will not tell anyone. From organizing events to provide access to a network, to help you raise capital, to find people to fill job positions, and of course to provide you with market reports. Today we are almost reaching the half of the season 3 of the Epic Online Technology Meetings. It looked like we were yesterday at Christmas, right? Time is flying. Today we are talking about robotics, but I would like all of you to pay close attention to the upcoming online technology meetings, especially, for example, next Monday we have a meeting on CMOS sensors, or in a couple of weeks from now we have a meeting on green energy. If you want to participate in those meetings, please register online and as soon as possible. That makes our life easier. And also let me remind you that for the first time ever, 2021, Epic is organizing also a set of quantum online technology meetings because it's my passion and also because it's the future of photonics. And we're going to address all the different markets for quantum technologies. We start on February 12th. For quantum computing, and on 26, actually, security and defense. So very interesting topics. If you have something that has to do with quantum technologies, or you just want to know what this is about, do not forget to join our meetings. And that's all. Today, robotics. And I would like to first of all acknowledge the cooperation that we have with the European Machine Vision Association. Thank you very much for the work that we are doing together. I love working with you. Also, I would like to thank our media partners, PhotonicsViews and AZO Optics. Thank you so much for constantly promoting all the job that our teams are doing. And also, let me also acknowledge the teams. This meeting wouldn't be possible without the support of Epic members. Today we have 4 sponsors. The first one is 4Jet, all the way from the UK. This is a company that is actually leading the evolution and the the revolution of process systems in the surface structuring and advanced laser manufacturing. And we go to Finland, all the way to Finland, we get Modulight, a company that specializes in manufacturing of semiconductor lasers, from wafer level all the way to developing those lasers into end user. They actually manufacture lasers for ophthalmologists. Vigo Ventures, all the way from Poland. This company is looking for opportunities for investment. If you're looking to raise capital, Vigo Ventures, I really, really recommend them to help you raise capital. They are actually financing, they are actually investing in photonics technology. And finally, the giant OFS, a Furukawa company. OFS is a company in EPIC that specializes in optical fiber, from specialty fiber to telecom fiber, any fiber that you need. It is multi-core, heavily multi-baud, dopant. You have to go to OFS. They have all the solutions for fiber manufacturing. And that's all, because I want to give the floor to my partner in crime when it comes to the laser industry, Dr. Moglia. Thank you very much for the amazing work you have put together. What's in the menu?
Thanks a lot, Jose, for the introduction. So as you see, this is the list of speakers that so the main speakers, because please feel free all to speak and comment. But this is not the way we like to see it exactly. We want to see you all better in this slide. That is our supply chain slide. And it's a bit special this time for this meeting because robotics is a bit for EPIC in between. So we have, of course, a focus today on the robotics manufacturers. So we have it there on the top corner on the right. So KUKA, ABB, DEMCON, Epson. So they are those that are really building the machines. But then what about the end user of robotics? So they are also, many of them are EPIC members, some are curious and just join us today. And then, of course, the photonics. So the photonics is easy. So let's not forget, this is the majority. All the part of this full supply chain for robotics, for the robotics is today here. We have also the future collaboration and the future evolution and development with the R&D centers. And so I guess we have enough of you here to have a lot of discussions. And so I would give the work back to Jose and we start.
Grazie mille, Francesca. This slide only represents the companies who register for today's meeting. So you're an EPIC member and you're missing your logo here. It only means that you didn't register for the meeting. Don't let it happen again. Please make sure that you do register for the relevant meetings to your company. This meeting is also live streaming YouTube. So my friends, hello YouTubers of the world, hello partners in crime. Thank you very much for coming today. If you want to get in touch with any of the participants today, send me an email, jose.pozo@epic-azo.com, and I will make the introduction. Also, please make sure that you use the chat in the YouTube channel. This is also valid for the people in the Zoom room. We have a private chat there. Use it to talk privately between each other and make sure you do business. This is a business meeting. And after the meeting, if you didn't get a chance to talk to the relevant person for you, just please make sure you send me an email, jose.pozo@epic-azo.com, and we make the introduction. Let's get the meeting started. I really can't wait to have to hear from the robot manufacturers. And we have one of the key companies in this segment opening the meeting today. I am Clarke, manager of software development at Epson. Will kick things on. Ian, thank you very much for opening the meeting today. The floor and the attention of everyone goes to Epson in this epic meeting.
Thank you, Jose. I think I need to drink more coffee.
I have a lot. I can give you some.
Okay, so I'll just share my screen. And if everyone can see it, I will start things off. So thank you, Jose, for that energetic introduction. I'm coming to you from Toronto in North America. So just getting the day started here, and I'll be ramping up my energy level, hopefully, as Jose comes in hot. As you can see from the slide, I'm going to talk a little bit about robots from the R&D side. Today, I represent Research and Development Center in Toronto for the Seiko Epson Corporation, and I'm going to talk a little bit about a project with machine learning and robot and vision, making a skilled robot. You can see our office there in the summer. It's very snowy right now. And let me see if I can go down. So just a quick overview for where I'm coming from within the Seiko Epson perspective. As some of you probably know, it's a Japanese company, about 80,000 employees worldwide, and mainly known for our printers, I guess, is our biggest product line, inkjet innovation. of course, also projectors. And I missed a session a couple of weeks ago, but the augmented reality glasses, the Moverio glasses, which we're also involved with. And of course, today's topic, robots. So these are the four sort of areas that Epson's focused in. And as you can see from the bottom here, and robotics and innovation, of course, I guess as a lot of people are considering, the combination of adding sensing and smart technologies to try and expand applications and create a future where we can get beyond the current sort of industrial hard-coded world and get into a new world of robotics. So that's what I'm going to talk a little bit about today. And I will go down one more slide. So R&D in Toronto. So we're mainly on the software side in Toronto, and of course, as is trendy and fashionable, I guess, working a lot with machine learning, machine vision, and adding those sort of skills to the robot line. We're basically focused on, of course, industrial, but that's Epson's main area right now, focus. But on the R&D side, of course, we're trying to look beyond that. And I guess I thought for today with the Photonics Association Consortium, I guess it would be best to talk about how we want to use the skills going forward to try and create some new value. So basically what we're focusing on in this particular area is, of course, to add a lot of sensors, mainly vision sensors, but force sensors as well. And of course, machine learning to try and expand, I guess, what one might say, what a robot can do to more of a skilled concept, I guess. So the main idea here is that as opposed to just being able to detect, one object and then manipulate that object and to perform one task of one particular type, to be able to train the robot to have a skill in that sort of area, so it can detect and manipulate and perform tasks of a variety or of a decent variability. So basically kind of trying to expand the concept of, okay, I'm hard coding the robot to do one particular thing to it can have a skill in grasping and manipulation, whether it be pick and place or pick and insert or any task that you might want. But the idea is to build up the robotic skills, I guess, to open up new possibilities. And of course, the idea with this is that you want to train at design time the skill so that you can then apply that skill in many different applications. And of course, to be able to adjust quickly for particular environments or skills or tasks that required at the customer site. And of course, as is the main point today, the key to all that, of course, is fast, flexible, and accurate sensors. So that's what I wanted to talk a little bit about, what our needs are in this area. So currently, we're using, obviously, a lot of RGB, RGBD, 3D cameras, both on the robot arm and also statically mounted. And of course, as we all know, that leads to a real variety of conditions, angles that things are being viewed at, environments that are being viewed from. And that leads to a lot of very high bar, I guess, for what we really want out of the sensors that we're using. Of course, we want to be able to control the light sources that we're using. Be nice to be able to control the projected pattern for the 3D cameras, to be able to tune that pattern to the specific environment and object that we're doing. Accuracy, a lot of times the 3D cameras that we've seen, are tested on sort of more of a flat surface. But of course, at the end of the day, what we really want are the edges and the corners, be able to preserve the 3D shape that we're looking at, both the smoothness of the shape, the 2D, 3D edges. Of course, we need to be able to preserve the holes, the complexity of a shape that we're looking at. And I guess to help with all this, we'd like to be able to support reinforcement learning and machine learning policies on the hardware of the camera for speed reasons. And probably the one thing I'd like to dwell on a little bit more today is the interface, I guess, meaning we see a lot of literature, a lot of products offering sort of auto tuning solutions and the ability to tune, but in the end, the level which we can do the auto tuning, can we able to specify target features like edges or holes or things that we say we want to be able to see this or see that? can we have an interface that allows us to tune the sensor on the fly to be able to see those things in a very sort of dynamic way. So I guess the control of the sensor, the accuracy or the fidelity which we can produce the scene, the speed with which it can do that, and then the interface, which I think is one of the key things, because of course most of these things that we're doing just get complex very quickly. And of course, one of the main problems is how long it takes someone to tune the system to do what it needs to do. And so how can we make a higher level interface that will allow us to auto-tune, tune on the fly, shall we say, or learn what the parameters are for that particular object or task on the fly, I think. And a lot of people seem to be offering that. We haven't found exactly what we need so far. So it's something that hopefully we can hear from partners today in that area. So just a very high level view, I guess, of what we're trying to get from our sensor need, all towards building to be able to, with both mobile and static sensors, to essentially build up the ability to not handle just for a specific object, but to be able to handle a range of variety of objects within a given task or skill. And of course, as you can see, since we're on the research side, this is a little bit farther out there on the timeline, and it's definitely sort of envisioning an environment or area where we're not in a probably industrial setting, but more in a post-industrial setting where it's a sort of more of a task changing daily type of arena, where perhaps the customer, what we envision is has a, they're doing something in a specific area, but each day the object that they're working with changes. So they need to be able to adapt to that quite quickly, and to be able to adapt to that very easily, I guess, is what we're aiming for with all of this. And with that, I think my time is probably pretty much up. So I apologize for the very speedy and brief overview, but I think I will probably leave it there and allow us to move on. So thank you very much to allow me to give this little brief overview of what we're doing in the Toronto office, and look forward to talking with you. Thank you.
Thanks a lot, Ian. That was exactly what we asked for. So you put also your wish list. That is good there. Maybe it's not really detailed, because the thing that is interesting for us is you just mentioned what you had so far is not satisfying you completely. Can you make some more specific example on what is now not really working properly that you would like for the future, and it's fine?
Yeah.
We like the also not a solution of today, they want a solution also to think about tomorrow. So good choices.
Yeah, so I mean, just to talk a little bit more about what's not working for us today. Well, first of all, most of the things come down into, as we know, because we're starting to look at it from a 3D with perspective. So in a mobile camera, you're looking at from different angles. Of course, reflectance and lighting, all of the usual problems that come up, and how to dynamically adjust to that. But main thing is the how, what's the word for it? When we're doing the auto tuning, as opposed to having an expert, say, okay, this is what I'm looking for, this is how to tune. We want to be able to automatically learn that based on what the task or algorithm downstream is looking for. So a higher level of semantic meaning. So if I want to look for edges or specific features, can I specify that and say, here's what I want to be able to see in the scene? Can the camera system now adjust to that and look to tune? So in other words, the interface between the algorithm, the application, and the sensor, could we have a slightly more rich, I guess, or higher level interface between those two components?
Okay, that was already a very good example. And now I guess I give the floor to our participants, because I see many questions. So we start maybe chronologically. Maybe it was partly already answered. So Simon from Jabil, but you can maybe formulate yourself your question and introduce yourself. You're welcome to do that.
Hi, Ian. Nice to see you. Very great introduction to the topic. So my question is, if you would consider hardware and software, where do you see the most challenging and restricting factors? Is it on the hardware side, or is it on the software side?
As usual, it comes to be a combination if you want the honest truth. So in other words, we can only get so far in software without the hardware giving us the backup. So a lot of times what we found is we start going down the software, try to get the control, but the hardware manufacturer, we don't have control over what we need to control, which is why I listed up there that, we want to be able to control the pattern or the projected, for the 3D sensor. We want to be, basically you need full control at speed. And that is proving to be challenging. So it's not an answer to your question, I guess, but I guess both need to be done and in, together, for it to work, is what we're sort of finding.
Right. It sounds like a 50-50 for the moment. Does that change over time to, let's say, more towards software or?
I guess that's an interesting question. If someone makes the iPhone of sensors and then we could just make apps, that would be great, I suppose. But I guess the question is whether there can be such a perfect piece of hardware. What we need is, like I say, we need full control and we need rich sort of computing or speed support, I guess, on the hardware. I guess if we have enough of that, it would be very nice to make everything a software problem, to be honest.
Right.
So hopefully it's software. I just, because that's easier to deal with, obviously. So.
All right. So would be great to talk after the meeting separately.
Thank you.
Thank you.
Good. So Simon knows already. So that's a good start of the meeting, and you can then talk afterwards about it. And okay, so the iPhone of sensors. This is already we have a, a very important word to remember. That's what you're looking for. But let's follow up with other questions. So we have Christopher, right? You wrote in the chat. Christopher, can you ask the question yourself? Carter Robotics.
Yes.
There you are.
Here I am. Okay, yeah. So you're talking about a task-based system. So that implies that there are, well, an abstract word, behaviors that are exhibited by the execution of the task.
Yes.
Is there some mechanism or some other corrective mechanism that you have to implement, I should say, to regulate any deviation in the sets of behaviors for each task execution? So for example, if I have a robot that's running a series of interactions with somebody, sometimes the machine behaves differently or slightly differently according to each task run. So it's not, my resolution is not always the same each time it's run. So I'm curious if you have any mechanism to correct that, or if you just kind of see how it goes.
Well, I think that one of the keys to the whole intelligence piece seems to be, obviously, if the machine and the system really is training, let's say I know how to go from A to B, and the variability I've been trained to learn is from X to Y, but it doesn't know the purpose or have any semantic understanding of what it's trying to do. Because if I read your question correctly, it's really more a matter of when I get a slightly outlying incident, or I have a thing that's not within the normal range of behavior or thing, how does the system respond, I guess, is really how does it respond to basically, I won't say an error, but a slightly out of spec behavior. And I think in my mind, that becomes the real, because what everyone expects from a machine learning system and what they expect from a human is that we handle, out of spec behavior relatively well, right? We can recognize it and we are able to then say, oh, okay, how do we respond to that? I think that the first step, to be honest, for us is even just being able to recognize it and fail gracefully, to be honest, is probably the first criteria. The hope, of course, is by giving semantic understanding or purpose understanding to the system, it's able to respond in a more efficient way. So it's my goal is this. If this were to happen, well, I can just move around and go this way and still accomplish my goal, right? So to try and let the purpose or the goal, goal driven, as you might say, become the framework for it to sort of handle these kind of, if I'm understanding your question correctly, understand, when something goes a little bit not to spec or outside of the normal range, how to deal with it. But I guess the first question is, can we understand what the range is and what's normal and what's not normal in that behavior? So.
Ian, I don't know if you actually met Christopher before today, but I have to tell you, Christopher, I am a fan. I am a fan of what you do. For those of you who don't know Carter Robotics, I recommend them to have a look at their website and especially at their YouTube channel and see the amazing things they can do as setting robots at human companions. Human companions. Christopher from Carter Robotics, thank you so much for joining. I'm a fan. Christopher, could you tell everyone what you do for a living? And this is a collaboration meeting. So what kind of partnerships would you like to do with these companies?
Well, I'm kind of exploring at the moment. We've tried some collaborations with large partners like Aldebaran, which the NEO you see, but we seem to fall victim of too good to be true. And then once they realize we're too good to be true, then it somehow gets absorbed by the company. So as soon as I started to talk with the CEO of Aldebaran and their business representatives, they started to do their own program on personalities, but they have not succeeded so far. So it's some bit of solace. So we're kind of fishing around for partners that are interested in highly developed interactive robots that have personalities. So we're a software company, but we also do hardware. I've got some prototypes. My whole desk is covered with them.
Oh, can you move the camera?
Oh, yeah, I guess I probably will.
Yes.
I got that one. So over here, I can't even see what I'm doing now.
Yeah,
Yeah,
show us. This is the
there.
thing.
There, we got some parts over here. Maybe you guys recognize what that is. But hold
Oh
on.
my God. I'm a huge Isaac Asimov's fan.
And then
So
these guys.
whenever I
This
see
is our-
people
this is one of
developing
the-
personalities,
Where's the camera going on?
oh my God.
Well, there's
So
stuff everywhere, and I'm quite a mess, but the wife seems to tolerate it.
Christopher, in your YouTube channel, you talk with your robots. That's something that I really admire. When we are here looking to connect the software with the robotics companies and enable the photonics technologies, there are many companies who are gonna want to follow with you. I just want to say welcome to this. Please continue asking the questions and thank you for being here. I'm a fan. Thank you very much. Back to Francesca.
Thanks a lot. So we really like these things. If you have your robots already in the office, I don't know, Ian, if you have something yourself, you can show it, feel free. But otherwise, I would go back to Julia from Intel because she had also a question. Welcome, Julia. Thanks for joining.
Thanks, Francesca. Yeah, here's Julia from Intel Labs, working on neuromorphic computing. I have a question about interface or integration of sensing and the motor control part in those skills that you envision. So how tight do you see that would be necessary? So one can imagine, a system of little control loops with very tight integration, or do you see a clear cut between the sensing part and the control part, and where this cut would be then?
Gosh, I hope it's clear cut, but yeah, it's a very good question actually, and one that the team is currently struggling with the design, especially on the control side. And we do. We've talked actually to Intel quite a bit on your sensor actually, for the business version of the RealSense. But yeah, we're trying, to be honest, to pull the skills to keep them separated, hopefully, right? So that if we can define the skills so that the perception part, then the motion part, and the different thing, grasping part, can be done separately. I hope, but obviously things that grasps that require force feedback and sensing all at the same time, necessarily that will have to be tightly integrated. And I think ultimately that feedback, with that perception feedback, it's going to be one piece. But hopefully that at least from a framework side, we can keep, as much as possible, the perception and physical interaction parts. What we're finding is the trickiest part is exactly at that point of grasp and at that point of manipulation, where necessarily they're very tightly integrated, I guess, which is one of the reasons we're asking for that sort of very full control over the sensor and ability to integrate that together, I guess.
Thank you.
Yeah.
Yeah, Julia, maybe you can spend a couple of words of your R&D work for Intel, because here, you know, usually you're not used to maybe to talk to each other because you are all on the background of the new sensors and new possibilities of the future. So maybe you can say a couple of words of what you are doing at the moment, Julia.
Sure. So we are very much on the research side at Intel. At Intel Labs, we're working on neuromorphic computing technology, which is mostly hardware for accelerating spiky neuronal networks, event-driven neuronal networks, and then naturally also linking to event-based vision sensors. And in my work, so I work on application of this technology, and in particular in robotics. And there we try to, bridge and close the loop. So do everything from perception to, planning and control in the same paradigm, in the same framework. Yeah, that's where I come from. Yeah.
And Julia, how may I ask you a question back then for the interface to control that, to set that up? Because what I've found so far is that, like I was saying, the higher level interface, like the ability to set a goal, so to speak, and have the system learn towards that goal rather than say, okay, I want, exactly this intensity, this parameter, whatever I want to, adjust contrast directly. I'd like it to be able to say, well, what I'm trying to see is this, or what I'm trying to do is that, and have the sensing system be able to respond to that. Directly.
For me, that's probably a question about the feedback, right, from the task level or maybe from the control level back to the sensor. And we are working on trying to enable that. So we have a little bit of a luxury in our neuromorphic computing system that we don't start with feed-forward neuronal networks. We have a flexibility to wire them up however we want. And we add a lot of recurrent connections and feedback connections all the way down to kind of low-level sensory inputs. And potentially we could also output to control the sensor properties. Yeah, so we find it a very important direction.
Yes, sounds very interesting.
Julia, thank you so much for joining. Julia, it's really fantastic. Ian, I have a question in YouTube, and it's for you and also for the rest of the speaker. The question is coming from Aken. I love Aken. XPK GmbH is asking how using a laser in combination with robots will help companies develop new products. Do you have any challenges for the laser industry?
Are you talking about laser from a sensing perception or sensing perspective, or are you talking about from a cutting perspective, or what?
So the companies that ask are actually developing both high-power lasers, ultra-fast lasers, and laser diodes, because it was also supported by Lumibird. He said, good question, Oliver from Lumibird. So I guess we can address both challenges, or choose the one you prefer.
Well, for us then, I mean, laser just another form of sensing, and at least that's what we're using it for. So by all means, the same thing applies to the laser sensors. Most of the time, we've found that, especially since the laser, we need a scanning mechanism, which tends to be a little slow, I guess. So if they're able to make a, some way of getting the fidelity of the laser, but have an area scan laser or something that would help us, a lot of times with the scanning, you have to end up the time it takes to do the scan, things can change, especially in a dynamic situation. So we find that we like the fidelity of the laser, but the speed for us is a bit of a problem.
Oh my God, I love that answer. Do we have Jörg Peter from 4Jet in the room? Jörg?
We do.
Is he here? Okay, I will come back to him, but I want him to later on, because he's going to talk later on, I want him to later on tell us about how to actually optimize that speed. But continue with the program. To have a question from New York, from PLX, Malcolm Humphrey. What's on your mind?
Hello, yes, I was wondering, Ian, are you looking at just cameras, or are you considering other sensing technologies? Because that could be quite relevant for my presentation a little bit later on.
Absolutely. Cameras, of course, are just it depends what you consider a camera to be, but you're talking about different wavelengths, or are you talking about things more like force and grasp and this kind of sensor?
Well, laser scanning as an example.
Sure. From my perspective on the software side, they're all the, yes, I guess is the short answer. Absolutely. Because of course, depending on what we're trying to see, sense, of course, we just want to pick the right tool to be able to see that. So of course, from our perspective, I'd like one common interface and have everything just be, depending on what I'd like to be able to see. I'd like to be able to change my wavelength. I'd like to be able to change everything on the fly so that I can dynamically adapt. That would be wonderful in my world. And I don't have to worry about anything under the hood. You guys take care of it all.
Sounds good. Yeah, we'll talk later.
Yeah. So now, Ian, you have to say really wait till the last speaker, so because Murphy will be later on, but definitely there is room for collaboration also for afterwards. So also offline, we are really pleased to put you in connections to all the possible helper for you. So it was really nice to start with you, Ian. So now I guess all the things you will hear afterwards will be also interesting for you. So now, first step, I would go to Michael from Roboception. So it's really nice to have you here today, and let's see what he can offer to Epson, but not only, and what is in your plan for today.
Yeah, thank you, Francesca, for the introduction. I'm just sharing my screen. I will talk a little bit today about vision sensors for robotics, and a lot of the things that Ian already mentioned. I think we have some initial approach to that in our products, but I will just give you a view from the robotics perception on the 3D vision side. So I'm Michael from Roboception, a company based in Munich. Basically, what is our challenge? So in most industrial production, for now, we have like standard approaches. We have the world ideally known. We have the robots doing the same things all the time. But most of the people are looking at the moment for versatile plants. So basically, they want to have varying products. They want to have varying processes. It can be that the human is interfering. So work pieces are at different positions. And somehow the robot has to be able to perceive that. And this is where we are proposing that actually 3D vision, so we are mostly working on stereo imaging, really helps here in combination with machine learning, applied AI, to solve this flexible task, because only the 3D vision gives you the scale that you need when you have varying workpiece to robot and effector positions. Usually that's the question here. And the task we are talking about, especially in logistics, where you have no knowledge about the objects, and in machine tending, which can be on a mobile base or with a stationary robot. Always you have to refer basically the robot to the workpiece, to the workstation. And this is what can be done with 3D vision. In addition to that, you have a multiple variety of robots on the one hand, and a lot of grippers. And the task, same as for the human, is actually solved in between the eye and the hand. And the question is, how do we really get this eye-to-hand relation for multiple tools and multiple robots? And this is what I will introduce a little bit in the following. It was nice that Ian mentioned it. He said he wanted to compute something on the camera, and this is what we are actually offering. So our stereo-based system includes an NVIDIA GPU, so we can actually run algorithms on board of the camera that really reduces the latency, because we are directly coupled to the camera chips on our system. So the RC Wizard, you can see here, it comes at two different baselines. Usually from a stereo system, the baseline decides the optimal distance in between the camera and the workpiece. And here we are offering two versions for mounting it on the robot with small baseline and a wider baseline to mounting it as an external camera. You can compute on board, and what we are usually delivering to our customers is not the image, but the object location, the grasp point, and all this high-level information, because we can compute everything in between on board of our camera. So we have the possibility to detect Apple text, QR codes. We have a SLAM module for mobile systems. Item pick is a tool for logistics where you know nothing about the objects to pick, just that it's in an unmixed bin and you have to find it with your suction device. Box pick is for palletizing, depalletizing, and silhouette match and CAD match are actually for machine tending, because in machine tending, you need to have an accurate placement position. In logistics, it's pick and drop, so you need to know an unknown part, pick it and place it and drop it. For industrial automation, you usually have basically an exact CAD model of the part, and you need to place it accurately. And then on top of that, we are using machine learning to basically give us a generality. So the accuracy in our case comes from classical algorithms, edge refinement, and so on. And the large variety of object or the large amount of parameters that we want to reduce, we usually tackle with machine learning approaches. And in this case, we fulfill both generality and accuracy. And that's the specialty that we do in our product here. So yeah, we are solving a variety of applications. I just want to give you an overview. So we are actually, sorry for that. We are not really in automotive industry, we are in general industry. So we have challenges in reverse engineering of architectural parts. We have logistics application where we get millions of parts that we don't know anything about before we have to pick them. Then it's machine tending parts for varying lot sizes. So from 1 piece to 100 pieces. We also did some application in the leather industry where we have a challenge that human markings have to be read and interpreted by the machine to be later on processed automatically, which is also a very a topic that's happening very often. And of course, mobile robotics. Our approach is that the customer has a very easy to use intuitive web GUI, because usually our customers are not vision experts. So all the technology behind has to be presented in a way that maybe a roboticist, which is not the same as a vision expert, has the capability to deal and set up the system. So it's about setting it up, working with it. And this is the challenge that we are facing here with our products. The key challenges that we still face is the variety of objects and then also the robustness for specific applications in logistics, where usually parts even have different difficult material properties, reflecting surfaces, shiny surfaces, but still that is the key issue. And of course, cycle time. So in logistics, you have to put like 1,000 items per hour. This reduces vision to be below 1 second always. And this is a big challenge that we have here. So we really have to process fast, have limited knowledge about the objects we are dealing with. And this is basically the challenge I also want to pose here today for the sensor community, for the robotics community, and also for the vision people in the group. And thank you very much for your attention, for giving me the opportunity to speak. You have my contact data here, and I'm happy if you have questions or any like that to answer them.
Well, I have a question. Who is the lady in the green dress next to you?
I think she's ending her duty in September this year, but she's a physicist, so I think it's a good idea to have her in the call here. Yeah.
Thank you very much for a fantastic presentation. It is really great that you are here. You have caught the eye of many companies in this industry, and we are really looking forward to help you be even greater. The first question comes from me.
Sure.
And then after we'll go to Jabil and Intel. But the first one comes from me. This is a collaboration meeting. This is what we do for a living, keeping companies together. What can you do for the 670 members of EPIC? And most important, what can they do for you? This is the EPIC question.
The great question. So first, what can we do for them? So basically, we can help them to solve perception problems in their production, in their environment, and so on. That's our key effort, especially if you're in logistics, industrial automation, also lab automation. This is where we are basically working in the domains to help you automate your productions and solve interesting perception tasks. That's what we can do for you. What you can do for us. We are developing software and hardware. So we are mostly focused on, let's say, stereo systems, but we are also interested in collaboration with, let's say, other hardware manufacturers of different sensing principles, where maybe our software may fit, or the other way around. So we are a bit flexible on that. What kind of collaboration can come out of the meeting with sensing principles? I was also interested in where can like tactile feedback help perception, especially in combination with grasping and so on, because we are working closely in end-of-arm tooling as well. So that's all the ideas where the community can help us and have better vision sensors.
Let's find you partnerships in the EPIC membership. The first one comes from EPIC member Jabil. Simon, what's on your mind?
The question I basically have is, I think it's the right way to address different applications. But in order to achieve, let's say, higher volumes and scale and reduce product cost, does the hardware need to be changed for each and every application? Or is this similar across applications and you simply tune the software?
Yeah, so good question. So in most cases, we actually are using the same hardware, because the good thing in 3D is that you're a bit flexible in the distance in between object and camera. So usually you have one hardware system and you use a different software to solve your problem. So on the hardware side, the interface stays all the same. You have the same camera and you can solve different applications from bin picking to palletizing, depalletizing to mobile robots with the same hardware, which makes it cheap on that side. Yeah, this is actually the approach that we are following. Yeah.
Simon, from Jabil, how could you help Roboception?
Well, we understand industrializing such camera modules and to achieve really, let's say, competitive product cost at scale, but already starting at lower volumes. So we need to tailor this around the specific product, but we can help on that. We understand technology behind that. We are not inventing everything new, but we understand it, and we are fully focused on manufacturing such devices.
Michael, and of course all the audience, if you are ever in Jena, drop by to see the showroom of AZO Optics in Jena. This is where they manufacture the GoPro camera and other items alike. It gave me goosebumps. Second question comes from Intel Labs, from Julia. Julia, what's on your mind?
Hi, Michael. So my question is about the latency. You mentioned 1 second, right? So is it where you are already now? Is it kind of the compromise between the where you are now and where the tasks requirements would be? And what would be the dream latency? So if if we could go like as low as possible, where would that be? Like, so can it be too fast or not? And maybe kind of additionally to that, we could maybe also comment on the trade-off between latency, the energy consumption, the precision of the task. Yeah, what is the current balance there, and what would be the dream point, design point?
Yeah. Sure. So we are having cameras that have 1 or 2 megapixels of resolution. So basically that is the camera image size that we are working with. This 1 second basically includes also computation until you come for the grasp point. So the image latency is way lower than that. So actually it's around 100 to 150 milliseconds before we have the image. And then it's more or less the computation on top to the grasp point and so on. Of course, like this, if you do the vision yourself, also this 100 to 150 milliseconds can provide some problem. But for control, I would go below that actually. So I think we need to be like, for having it in the loop for fast moving, I think below 100 millisecond would be optimal. But that's a question of also like the connection, the bandwidth in between gigabit Ethernet, all that stuff that comes into play here. So this would be great. If you go much lower than that, you also have some physical problems, because usually changing lighting conditions and so on. So we are using a lot of the 40 milliseconds for the camera exposure time already. So there's some physical limits to it, I would say. Of course, biggest pixel, smallest exposure time, and then lowest latency would be nice, especially in robotics. But for most of the applications that we're using it right now, it's not directly in the control room. So usually it's a target direction that we are giving. Of course, if we are more in the loop, the more important latency gets. That's the middle long answer.
Michael, opportunity for collaboration here from the YouTube universe. Ficontech is a company in Epic specialized in the active alignment and assembly of components for optoelectronics packaging and testing. And they are wondering, what is the smallest object that can be seen, detected with the cameras?
So the minimum distance that we have is 20 centimeters. And we usually say that if you want to recognize also orientation and position of the objects, it's, let's say a good size is 1 centimeter or so, if you want to detect it, because still you need to put a grasp point on top. That's not the physical limit of it, but in case you want to go for gross points, we usually say 1 centimeter sized objects are the ones that you can detect quite well in that distance.
Thank you very much, Michael. And thank you, Josue Parra from Ficontech, for asking that great question. Thank you, Michael. I want to go back to Ian. Ian, I want to come back to you from Epson because your presentation was out of this world and the room for collaboration that it enabled was also out of this world. In the Q&A, we had a question from Karen Goldberg from HoloOr. Karen, what was on your mind for Ian?
Thank you for the introduction. My question was, would you consider doing the integration of sensors and optics together and the projection module itself, or do you need something that is a complete module for you to use?
Well, of course, the easiest would be if it was all done, obviously. Then it's all integrated and I can just use it. That's obviously the best, but I guess it seems that at this stage, I feel like still full control is, how to say, probably it's kind of thing that you want to be able to do both. You know, if it works, then of course we don't need to touch it, you know, and that to me is depends on the interface that we're able to say. So if we're able to say, what I'm trying to see is this feature, those features, and please just make it always visible, no matter where the camera moves or how the lighting goes. Please, can you just maintain visibility on these features? If that interface exists, then I guess we can just use it directly. So that sort of feature level interface. Otherwise, we have to go lower and get more control and do it ourselves, basically, right?
So I was aiming more to the laser options, which you discussed. You said that with the laser, it's just too slow with the scanning. So if you had an option to do a flashlight or to scan an entire area in one frame, would that be something that's worth your while, even if it means that you need to do the integration with the optics on your own?
It's a tough question to answer off the cuff, but
Sorry. I'm just trying to understand because
it may be. So again, for us on the using side, on the vision side or the machine learning side, we don't. It's a toolbox. So as long as it's fast enough, I guess. It might be worth it. I guess is all I can say. We'll have to go into some more detail maybe to find out.
Yeah.
Ian, thank you so much, Karen, all the way from Israel in HoloOr. Thank you very much, Karen. Ian, in the previous Q&A, you challenged the audience with the scanning speed of the laser system. In that challenge, when it comes to incorporating lasers for many industries, for the surface structuring or for the advanced laser manufacturing, scanning is one of the problems. For Jet, York, you are the key company in EPIC for the ultra-fast laser structuring, advanced laser manufacturing, and ultra-high-speed scanning has been one of the added values. York, how do you address the challenge of the robotics companies that they claim that we need faster scanning solutions?
Well, I guess there are two ideas to scan. One is what we do to provide a solution to a customer is scanning a laser beam as a means of material processing over a surface. But what I think we are all also, of course, looking at is the scanning as a means of doing machine vision. And in a lot of cases, if you talk about detection of geometries or parts or a certain surface, you would be looking at, for instance, sheet of light cameras where you have basically laser distance measurement to detect three-dimensional objects. And we found that scaling up that is, it's certainly in theory, there are many ways by, let's say, either one, if it's a laser materials processing scanner or a camera scanner, by of course mounting them to an access system or mounting them to a robot and speeding up such a process by doing that on the fly. What we find challenging is, I mean, you have all these bits and pieces of technology, and in our case, you talk about a laser, you talk about a laser scanner to tell the laser beam where to go. You talk about machine vision to find out where your object is. You talk about metrology after the process to detect what's been happening on the surface. And it all can be assembled, but putting all that into a system becomes pretty complex in terms of software development and total CapEx and cost. So what we are really looking at is how can you reduce the complexity in teaching, how can you tie that into software without having these super complex machines which have more and more intelligence, and the processing time of the one system is eating up the capability of the others. That's the kind of headaches we have as integrators or solution
That's a lovely
providers.
headache. You know what who I want to bring to the table, Jörg? I want to bring ABB automation to this. Jan, thank you very much for joining the meeting today. Thank you for accepting my last minute invitation, and congratulations on the growth that you're doing at ABB. We are here talking to Epson and Forget about the need for faster scanning for laser-based manufacturing. I know that that's one of your strengths, Jan. So could you comment a bit on that, and what kind of challenges and perhaps opportunities for collaboration are here?
Just one example for well, to myself, I'm a physicist, went from PI to AB.
We had, I muted you for a second by accident. That happens with the live world. So can you, yes, you're a physicist and you came from PI 1 year ago. Yes.
Yeah, and now I deep dived into automotive industry, so producing car bodies and so on. And what our challenge is, we have to be more and more flexible, produce on the same production line different kinds of parts. And when it comes, for example, to laser scanning, and you think about flexible lines to be ran by AGVs, the subject of safety gets increasingly more important, and that's basically one of our. And laser scanners, or the laser welding itself, is for car bodies getting more and more important, of course. But I can't give you a specific requirement or specification we have to achieve here. So this is not so much what I can tell you. What I'm more interested in is subjects like bin picking, and when you think about those applications we've seen from Roboception in automotive industry, there is also from ABB a huge product range for flex picking things. And what's actually the difference here? Because you mentioned to be more in a lab environment doing that automation, and I was just questioning myself, why is there such a big gap between research and between lab environment and doing automotive industry? How to close that gap? Maybe
because we need more often ABB and KUKA and companies like that in this kind of meetings. And today you're actually enabling this. Thank you so much for this, Jan. And I want to have you more often at these meetings. Michael, do you want to address the challenge of Jan?
Yes, sure. I mean, of course, there's a big difference in between. I mean, we have been talking about bin picking for many decades already to keep productive in industry. One of the key challenges is, I think, it comes with a lot of parameterization. So this general approach where everything works out of the box is really hard to achieve. On our side, we try to bring it to product in terms where we basically fix on, let's say, unmixed scenarios. We have CAD models. We're using the machine learning to detect it and reduce the parameters, because that is really the expert knowledge that you need. You always tune your algorithms so that they work. And this is something that people on the shop floor don't really do. So, and this is one, actually it's usability, and then basically the understanding what the system does behind that. And we've been working on that from the very beginning, because I see this as a key barrier. It's not the technology, it's the way you use it and the way you parameterize it. And you have the gut understanding that it's actually working on site, and you have the trust in that. I think that's a key challenge here.
Michael, there's a question from you from Leuven in Belgium. IMEC. Virginia, what's on your mind? Virginia from IMEC? I think we may lost the connection, but I have the question here. How important is energy efficiency for Roboception? And can you target also battery power applications?
Yeah, so it is actually not the key focus of what we've been doing so far, because usually we have 24 volts connection for that. It can work with a regular battery. And we also use it for mobile application where basically battery power plays a role. We are using approximately 10 to 15 watts because we have a GPU on board, so that takes some energy. Of course, can be reduced in future, but at the moment, that's where we have like a decent runtime for the mobile robots we deal with. For drones, it would not be okay.
Michael, thank you very much for this. And now we're going to talk to one of your future customers. This is a company that I love. I go to the Netherlands. Goedemiddag, Jeroen. Thank you very much for being with us today. Tell us about DEMCON Robotics. The floor and the attention of everyone goes to Jeroen. This is a rising star in this industry. Goes to DEMCON.
Hi, I hope you can share my you can see my screen.
Gorilla Glass clear.
My name is Jeroen Minnema. I'm a mechatronic system engineer from DEMCON from the Netherlands, and I'm going to tell you something about our efforts in the robotics area. Oh, yeah. So first of all, DEMCON is an engineering firm in the Netherlands with about 700 people, 400 engineers, and we are working on various business units. And well, mainly today I'm going to tell you something about the robotics in which I'm working, and also the branch with the optical systems. So well, what I've been working on at DEMCON for a couple of years now, first of all for my master thesis, and then currently as an engineer as well, together with other people, is DEMCON's sensor fusion framework that we've been developing. And the challenge that we see in the industry is that for different kinds of robotic systems that we as DEMCON are developing, being it drones or pipeline inspection robots, you have to combine different sensors to estimate a robot's position and orientation, and also to be aware of the surrounding, the mapping. So that's basically the problem of SLAM, simultaneous localization and mapping. And what we see is that for every kind of robot, being it a driving car, a rover unit, or a drone, or a pipeline inspection robot, you need different types of sensors. And they really depend on the situation that the robot is operating in, what the ideal setup is. So we at DEMCON have been developing a system, a sensor fusion framework, where we can combine all these inputs, being it wheel odometry and IMU, LiDAR, using laser techniques, or stereo cameras, and also including April tags and other kinds of sensors, even Wi-Fi measurements and range bearing measurements, to come up with a robot's environment and a position. And the idea is that we can do this for every type of robot. And that's also how we've been approaching this problem from the start. So we've been developing a framework that can combine all these types of sensors. And what we can do is we can combine the advantages of all the specific sensors to tailor them to the system that we're working in. And I want to share you an example of a pipeline inspection robot that we've been developing. And the idea of this robot is kind of a snake with several different modules. And especially right now, I want to focus on the head, because it has a camera and also a laser finder to detect its systems. But the thing is, this robot has to be operating in a large pipeline network where it has no GPS or anything, but it still has to be aware of its position. And we can combine the information that we know on beforehand of where joints are, or cross sections or T-joints or whatever. We can combine these informations in order to basically locate the robot under pretty difficult circumstances, because the wheels experience slip, but we can compensate that using an IMU and using the camera to detect, to use basically computer vision and also AI to do this. And the cool thing is with this robot that we've basically training this robot beforehand, before it even went into the pipeline network. And what we've done is that we generated artificial data. That's what you see on the right, synthetic data using basically our efforts in AI, and then basically to train the robot detecting those joints. And then as you can see, it matches quite well with the reality, and we can use those things to detect the joint, and we can train the robot to be navigating before it even entered the pipeline network. So sensor fusion is all about combining strengths of individual sensors in many different circumstances. So being it both for a pipeline inspection robot, a drone that's flying, or a rover that's driving around. And using this to combining sensor fusion with artificial intelligence enables us to do this in a cost-effective and time-efficient way. We can train a robot before it even entered the pipeline network. And DEMCON is a system integrator, an engineering firm that can combine these techniques to do this. And we can do this from the start of a concept up to and including the production. And what we're looking for from the industry are valid business cases where robotics could be the solution. Thank you for your attention.
Thanks a lot, Jeroen, for your contribution. Very interesting.
You're welcome.
And it's always very challenging with DEMCON, because I know you do always OEM special products, and you are always doing a lot in-house, let's say. But here we want to hear also, okay, you look for business cases, but what can, let's say, more your supply chain can do for you? So here in the room, do you think that there's someone there that can help you and you get a collaboration with to specialize, of course, your robots from both software and hardware? So you are free to pick up some of the things that you prefer.
Yeah, well, actually, at the end, the performance of this SLAM, or basically our entire framework, our sensor fusion framework, depends on also the performance of the sensors to begin with. So better stereo vision, or a better LiDAR, or better photonic systems, basically to begin with, better hardware definitely improves the performance of the system. So also in that sense, like better, if you start with better sensors, your results will also be better. And I think, that's basically would be my answer to the question. So we are also always looking for better hardware to also improve this, because as you can understand, like the context of the robot that is working in the pipeline inspection are pretty difficult to do that with. Yeah, you need basically the best of sensors to begin with, and a very strong software setup. Otherwise, you won't manage.
Very good. But then Julia has another question from Intel Labs, to be more precise.
Yeah, a very quick question in the spirit of time. So I wonder, what is in that sensor fusion box? You say AI. Do you mean deep learning by that? Or is there something else, something more, combination of things?
It's a combination, actually. We use multiple things. We've been using basically, indeed, normal AI classification, as you could say, to recognize joints, for instance, for the pipeline network. So we can use basically the classification, but on the other hand, we also are using reinforcement learning. So basically to train the robot and to see the outputs of the navigation, and if they are according as what we desire. So we use basically a combination of multiple things. So indeed, partly deep reinforcement learning, classification, and also we use AI basically for generating synthetic data. So we use many different things. And on the other hand, we combine it with also traditional SLAM techniques. So it's really in the combination. It's not just AI, but it's also original SLAM techniques.
Very cool. Thank you.
You're welcome.
Hey, Jeroen, I am so happy that you're here. I am a fan of what you have done so far. I know you are extremely young, insultingly young, if you ask me, but you are just starting at DEMCON. You started a company during your studies. You have won awards for energy efficient cars projects. It is great to have you with our network. I was amazed by this slide, and you went too quickly through it, because there's a lot of opportunities here. So I want to come back to this slide. When we are talking about sensor fusion and AI, we are actually going inside the pipes with optics and with cameras to investigate them. You are a robotics genius, if I can say that. Can you tell me a couple of challenges for companies that could help on this project?
Well, what was definitely a challenge in this project is to be able to accurately detect the joints. So, and it relies on reliable vision engineering. So the camera input has definitely, and to do that properly. And also at the end, it's an inspection robot. So yeah, there are challenging circumstances. Initially, there's no light, so but the robot also has to be traveling at a given speed. So those things are actually what make it more difficult to be. And also the main challenge would be, I guess, to do it in a reliable way. So the robot is navigating through a big network, and it always has to be working, because it would be very difficult to get it out there if it would get stuck.
There is no light. So here we're actually inspecting something in the dark, and you want passive imaging, right? You want to avoid having a laser in there, taking into account that you don't know the material that is going to be facing, right?
Yeah, that's also true. Yeah. And basically, the problem is also the robot has no GPS, so localization is also a difficult thing. So yeah, that's also what the optical systems also come in handy, because only using an IMU and the odometry wheel information would not be enough. So you really need the vision capabilities to keep track of where you are.
one thing that I always wonder when I see systems like this, which I love, is the use the wavelength that you want to use for the passive imaging. Some people will say infrared, but we are talking about pipes that get really warm sometimes, and it is very hard to know the temperature. So infrared could be maybe out of the question. When you're talking about doing a low light camera, is there any particular technology you have in mind? And I'm sure that this is a challenge and many companies would like to actually cooperate on this.
Yeah, I only can say that this is still a challenge. Or still, and we've also been experimenting with different things. Indeed, you raise a very valid point that the infrared is difficult. So yeah, it's a difficult question actually, and we've been experimenting with different setups. And sometimes you can generate your own light. We've also been trying that. It partly solves the problem. And what we've also been using regarding the localization is also some points do have light, and we can also use that, detect those to see that we are there. We can use them as a kind of checkpoints, like exits, for instance, and then we can generate some light to see to detect those points. So that also helps us actually.
Thank you very much for that. And I think there is a lot of room for cooperation here. I will make a lot of introductions for you to talk about this. But I want to know from Michael, because your company has been already addressed a couple of times, Roboception, and you are the link here between different companies. Michael, this is a challenge. We are talking about going inside the pipes and actually not knowing the temperature and the conditions around with very little light. Is there any particular room for cooperation here?
Yeah, sure. So when I was watching the presentation, I was just seeing that basically on our sensor, we also have an IMU on board. I didn't mention that. So visual odometry is always a challenge in these kind of environments. And we had a similar application where we had the task to deal with a lawnmower in the dark, which we used infrared light to basically do the navigation. But visual features look completely different depending on the light. So I would really be interested to discuss it, to see how you deal with the drift of the IMU, how do you deal with specular refractions and your visual odometry. So there's a million of things that came to my mind when I saw your specific case here.
Yeah, very interesting. Yeah. Just to quickly address, like the idea is that when we can detect the joints and use those to compensate for the drift of the IMU. That's the idea. We can use them as some kind of reference point, a checkpoint. And we know some of these, we know basically the structure of the pipeline network more or less before. There may have been maintenance works or adding additional pipes or things, but we roughly know it beforehand, and we can use that information to compensate for drift. That's the idea, at least.
Okay. Yeah, I also have another use case. If you go for like robots that are used when buildings collapse and so on, there usually you have to put these snake type robots also inside. It's maybe another interesting use case for you.
Cool. Sounds interesting. Yeah.
Jeroen, we have a very, very interesting comment in the chat from Caleste, Jan Vermeeren. Thank you very much for being with us here. What's on your mind?
Okay, good. You said there about reducing the light levels and so on. But yeah, the problem is that at a certain moment you jump into the physics. And it means that if you lower the light level, let's say you have less photons in your image. And as a consequence, the signal to noise ratio due to the photon shot noise gets lower and lower. That's one thing. The other thing is if you look into the infrared, certainly if you go to mid-wave and long wave totally, that the contrast in the scene is much lower, and that sometimes it's very difficult to get a scene which is containing enough contrast to do any feature extraction.
So, Jan, this is actually okay for visible light, but when it comes, for example, to X-ray, or when it comes to optical coherence tomography, we maybe perhaps be looking at other challenges that could not, but don't really need to depend directly in the amount of photons. Is that correct?
No, if you see, certainly if you go to X-ray, okay, good, you have larger charge packets in your image sensor, but that is due to the multiplication effect. So one primary photon generates multiple electrons or holes, but essentially, let's say the shot noise is still there, and that's caused by the primary photons. So even there, you have to, let's say, accumulate enough, let's say, light particles simply to have, let's say, sufficient signal-to-noise ratio and hence also contrast.
Jan is going to be one of our participants in the meeting next week on CMOS sensors, and we have already lots of end users being around the table. Jan, I want you to have this as an introduction. Thank you very much. But I want to go now to Pleora Technologies. Neil Bolster is here. This is one of the companies that we have in the Industry 4.0 side. Neil, thank you very much for being with us. Thank you for joining the meeting. What kind of cooperations would you like to start after this meeting?
Hey, thanks. And you got my name right. Most people say Niall. It's a long story. I think what we're looking for is, and it's very.
Oh, you are muted right now. This is something that happens live, but it wasn't me this time. You see my
Okay,
hands.
okay. Can you hear me now?
Yes, loud and clear.
Very good. So it's very interesting topics, and maybe for Ian, I'm not sure if you're aware, Pleora Technologies is a Canadian company. I'm based in Ireland. But what we are doing and what we're looking for some collaborations is we've been working on AI technologies now for 18 months. And what we found in industry is, although AI is a buzzword, people, end users are finding it difficult to deploy it. And we're working with some customers on a plug and play system using Python scripts, which is very much taking away the whole difficulty around deploying AI. And if people are interested in more in the technology and how we're learning to, or how we are achieving to train our models quicker than the standard solutions out there, I'm free for a conversation after this.
Thank you very much, Neil. You're going to have a lot of conversations because I have something in mind now. We're going to have Ian from Epson, Neil from Pleora Technologies, and our next speaker, which is Opto, Sami, Fathallah, working on perhaps a project I have in mind about AI for real-time inspection, because Opto is a key company on that. Sami, thank you very much for being with us today. Tell us how we can help Opto being even greater than already is. The floor and the attention of everyone goes to you.
Thank you. Sorry, thank you, Jose, for the introduction. Just some words about Opto.
Let's share the screen first because we can't wait to see the slides.
It might help.
So bottom of the screen, arrow up, it says share screen. I love Zoom and live on YouTube at the same time. Let me just say hello to all the YouTubers in the room. And remember, in the participant list that you have in the YouTube channel, you see all the people there. Some of them are in the Zoom room, others are in YouTube. We have access to all of them. The floor is yours, Sami.
Okay, thank you. So Opto is maybe a bit different from the great companies which presented themselves previously. Our core business is actually in more in the microscopy world, which is maybe a bit the difference compared to what all we have discussed or have been discussed previously. And so the company has been founded in 1980. We are something like around 50 people worldwide, with main let's say the headquarters located in the Munich area, where you can find all the hardware related design, optics, a lot, of course, mechanics, electronics, and the manufacturing is there as well. And there is also how to say, location in France, where I am actually, so southeast of France, where let's say we are more the software center of competence, software engineering for the group. So our main markets around microscopy are biomed, semiconductor, mechanical industry, manufacturing, and let's say we are quite a lot with machine builder actually. So the two main, how to say, products, two main activities that we have are what we call imaging modules. So which are how to say, I would like to call them tools to provide the best image. So to machine vision developers, machine builder, where having the right image is very important. We have seen many people talking about that here, and getting a good image is a sometimes difficult combination of sensor, of optics, of light, of sometimes other things like projectors, as we discussed, and motors, and so on and so on. So we are really working hard about these modules, which are a complete subset to provide the best image as in a best image in a complete module, easy to integrate. It's really a key point here, especially for machine builders. The other department, I would say, is about OEM module, which is a big part of our activity. And so the idea is to provide very specific modules to customer in very different industry. These module being usually the core of a complete system, of a complete machine in I don't know, surgery, in different metrology system, or any kind of machine, or in for POCT, or different biomedical application, for instance. So these are the two main parts. And we start working on what we call job modules, which are, instead of providing the best image, providing the best result. So it's really dedicated to one task or another, based on processing, based on artificial intelligence when required, to provide the result for, as I said, machine builders mainly. So just as I mentioned previously as well, we have a strong focus in biomedical markets, and especially our life science. We have a strong knowledge about fluorescence imaging, and especially multi-fluorescence imaging, where we have developed quite a lot of skills, let's say, and know-how these last years. And when it comes to robotics, I would say just an example of some project we have working on, that is about sorry, that was a project in a collaboration with the University of Würzburg. And the idea here was to so it's a research project, and the goal is to work very roughly about being able to how to say, not design, sorry, I don't find the right word, but to make customized, patient customized medicines, because it was around the mucoviscidose. Don't know if it's the English word for that disease. And let's say typically it's a disease for which some medicines, some drugs exist, but it's a combination of very many things, many different products, and very expensive, and combination. As far as I understood, it could be like many thousand euros a year of drugs, whereas the efficiency really depends on the patient. So the idea here of this research project was to be able to make a biopsy, to make tissue engineering, and to multiply all testings to evaluate a different combination of drugs. So thanks to fluorescence mainly, this is, let's say, more our parts. And doing this requires, or to be efficient, a lot of automation. And this is where the robot plays its role in this project, in making the whole process from getting the, let's say, making the tissue engineering, preparing the screening, up to let's say our part, which is about the imaging. And so it's a big market, or let's say a big domain for us to work on this high throughput screening, of course. And unfortunately, here everybody knows more or less what is POCT, point of care testing these days. And so this is making fast tests can really take advantage of automation / robotics. So what we can propose, let's say, to Photonics, or let's say to EPIC members, is systems for optical system, and that can bring machine vision to Photonics, especially in the in the microscopy scale, with strong automation. And we have some experience also together with robotics companies that we would like to improve. Maybe more in a larger scale, but I'm pretty sure that there is some room for robotics in or in association with microscopy. What can EPIC and EPIC members, in which, how can you help us? Of course, we are evaluating different and are integrating in our modules different technologies, are looking for many technologies every day, bring its lot of batch of innovations. And of course, we are really interested in getting some, let's say, new products, new technologies that could be integrated in our products. And thank you for EPIC for this time, for giving us this visibility. This is what we are looking for, and would be really it would be really nice if we see more and more microscopy related events and topics.
Thanks a lot, Sami. Thanks a lot for introducing also Opto again, and then give it the visibility is, of course, one of our of our task. So now going back a bit to, you already mentioned what can the EPIC members here and also the whole audience can do. Maybe we get a bit more specific on some details. So like if we think about what we mentioned before, for example, Ian needs a lot of reliability and also to be fast. Maybe this is not what you have in medicine, because it's something that you want more accuracy, but not necessarily a fast process. Is it the case? So what is exactly the challenge that the Photonics should support you with?
Yeah. Actually, I would say one of the challenges currently, especially for multifluorescence, for instance, is finding the right components. So it could be lights as well as image sensors that enable us to make a tight and really, as I said, one of our key points usually when we deal with the customers' requests is to make something that integrates easily into a whole system, into a machine, and then that enable let's say a good throughput. And fluorescence, indeed, usually we are in processes that are not about 100 milliseconds, but fluorescence is in many cases, at least in biomedical application, a low light application where we have to expose a lot. And this is actually the same also in semiconductor industry, when you have to go beyond 1000 nanometer or whatever to let's say inspect wafers. And actually having proper sensor that enable us to reduce exposure time is a key point. When it comes to light and LEDs, for example, if because we use more and more LEDs, having a good yield for LEDs so that we can have a lot of power with a limited amount of energy is also part of that. These are things that comes into my mind, but maybe let's say my German colleagues who are more in the hardware can talk about that for hours.
Yeah, but then we go back to the software, maybe. That's the point. Because maybe I ask you to comment maybe what we heard from Niels before. So would it be a Python-based platform actually help also in your part, so in your applications, or you don't see there a valuable contributions?
We also recently went into let's say machine learning, or deeper in machine learning and deep learning, but what I think we are good at, we have been good at for years, is also, and I think it's a trend we should follow. I mean, there are many experts in deep learning experts companies, even in specialized in machine vision or whatever. But then, okay, as Michael from Roboception mentioned, usually you have a lot to tune and whatever. I would say, before becoming the best expert in deep learning, I would say what we could do, this is also something I did not introduce in the presentation, sorry. It's also, we have the skills to provide, once again, the best image. And in deep learning, especially applied to automation, applied to industry, we are not, usually our customers are not Google, who can easily have billions of images of a dog or a cat or whatever. So having the proper data, even for all this artificial intelligence process, is, in my opinion, a key topic. And this is where also we can play a role. So this is part, this comes from the our imaging module that provides the best image, and this is also something we could provide through a technology we have that is called Solino. You can have a look at our website or through different LinkedIn posts we can do from time to time to let's say to generate an enhanced data for learning.
Okay, this is very interesting, because you're right. Usually there is a bit of a unbalance if you're not a huge company to have access to be able to train your AI. So I understand the issue. So that's good that you can also support there. And now is maybe time to go a bit back to the hardware. So we know we didn't talk yet about what the fiber sensing, so what the fiber actually can do for sensing. And so it would be maybe time to listen from Udo from OFS. What is in your mind, and what was your interest in being in this meeting today?
Yes, hello. Thank you, Francesca. So I'm working at OFS in the specialty fiber division, and I just try to share my screen now to see an overview what we are doing and which ideas we have to help in this, let's say, wider range of robotic applications where fibers might play a role. So.
Yes, it's about to be there. Yes.
So you can see my slide?
Yes, it's not in presentation mode, but it's maybe large enough as you want to go. Yeah, perfect. Now it's
okay.
great. Thank
yes,
you.
I pressed the wrong button. Sorry. Yeah, so OFS specialty, we are material experts. So we are really we start with silicon and other chemical materials, making fibers. And of course, on the other hand, in the application, in the photonics world, we are also expertise. With software, we know that software needs us to be enabled, but we are really physical layer people. our company is fully vertically integrated, so we really start designing a glass preform, drawing fibers out of this preform, and going up to complex photonic assemblies. So we help, for example, photonic integrated circuits with extreme band intensity fibers within a chip, or polarization maintaining fibers for such applications. And looking into the robotics world, I try to ask the question or answer the question what OFS can do for you. So despite being a part of a very big organization, the Furukawa company, OFS Specialty is a small organization within a big company. So we are highly flexible and working on customized designs. So we are doing special fibers with, let's say, special numerical aperture, special dopings, core sizes, cladding sizes, etc. Making cables, of course, also telecom cables from our colleagues, but our cables are really different. So they are highly flexible, extreme temperature ranges, or chemical resistance, and also assemblies. This could be combining lenses for a OCT assembly, for example, optical coherent tomography, which we believe is one hot topic around sensing imaging in the robotics world. We do on the other extreme, so sensing is a few photons to count and identify. We do power delivery fibers for up to kilowatt lasers, so directed energy stuff like this, and let's say material processing lasers. So we make here the delivery fiber, as well as let's say stone ablation in medical. We look into medical surgery very deeply. So here we make a sensing fiber based on multi-core technology, that you know exactly in which position the device, the endoscope or something like this, is in the human body, to guide the robotic machine to do the job without failure. What we would like to get from the EPIC community is, we would like to collaborate in an early stage of a new development. We have experience deeply on, let's say, the fiber side, but honestly, not so much on the robotic side, on the application. So if we work together from scratch, we can guide you and you can guide us towards a optimized, customized solution. And also, we normally make prototype designs for a special application, and we need the evaluation in the field, in the application, because we do not have such devices in our labs. We have, of course, all this high-end photonic test and measurement equipment, etc., but not really see a final application.
Thank you very much, Udo. And this is one of the key companies we have in EPIC in the fiber solution. So for any fiber requirement, please contact Udo. I'm going to reach now one of my favorite parts of this meeting. You know, my favorite part of the meeting is to talk about LiDAR, because everybody who knows me knows how much I love LiDAR. And when it comes to matching robotics and LiDAR, we always have the problem to know what are the unmet needs. I have in the room, I think I do, Santiago Royo from Bimagine in Barcelona. Un abrazo, Santi. Thank you for being there. And we have in the room also Simon from AZO Optics. And we have in the room also Ian Clarke from Epson and Jan from ABB Robotics. I want to have a little bit of a discussion on LiDAR and robotics now, next 5 minutes, because I think this is a very important topic. Santi, Bimagine was in the beginning, or actually identifying automotive as the key segment. And in the last years, you are also diversifying, addressing also other markets. When it comes to the robotics industry, what is the position of Bimagine as a LiDAR solution supplier?
Well, the main point that we have and the main contribution that we make is that we are able to develop, of course, a very good LiDAR that we have with very high resolution. We got 200 or 300 vertical layers, which is very good for different types of robotics applications, essentially oriented to vehicles. But the other point that we contribute is that we are able to integrate up to, I don't know, 14 different imaging modes tailoring the unit for vision to the application that is needed, which means that we can fuse the LiDAR with a camera, with a thermal camera, with a polarimetric camera, with any type of combination that you can, which is especially good for seeking applications where environmental conditions may be hard, which related to robotics pick and place maybe is not the most obvious solution, but of course, there are several other types of robotic applications where we can be very, very helpful with our capability of developing the system or making tailored specifications, combining LiDAR and any 2D imaging mode, or adding a little bit the general standard solution that we are about to commercialize in the coming weeks. We will speak soon with you, Jose, about the launching of the product. And then we will have a standard solution including that thing. So that's our main contributions on LiDAR.
You know, if this was a real meeting, we would go now all for a beer and we will have my love debate in which LiDAR is not an imaging technology, LiDAR is a sensing technology, it's not for imaging. But this is today a robotics meeting, so I want Simon to give me his 2 cents. Simon, you work very hard on bringing LiDAR to the robotics industry. You also push EPIC to address that topic as well in the past. Simon, what is the current state of the art and what kind of opportunities, challenges do you see in LiDAR for robotics?
So I need to extend that a little bit.
Please do.
So we are not, let's say, pushing specific technologies. We have a broad understanding of different sensing technologies to enable autonomous driving. Could be in automotive or for a car, but can also be in automotive robots. So we are, let's say, capable of doing this from an engineering perspective and also from a manufacturing perspective. Still, we feel that there's a huge drive down in cost. To reduce size and form factor to enable, let's say, reliable sensing in different lighting conditions. So there are quite a few challenges still to be tackled. Let's say high-end, highly costly solutions can do this, but at the end, it's all about driving costs down.
Yeah, really. I mean, come on, a robot is super expensive. Do we need to save 10 euros on a LiDAR?
I think we are talking higher levels of what you can save. And if you look at the quantities that are forecasted to be in the robotics market, you will come to the point that costs are in the middle of the attention.
Ian, in your presentation, which was fascinating, you talk about the 3 sets of challenges. You talk about control, accuracy, and speed. When it comes to the accuracy side, LiDAR has been identified as the way for actually detecting everything around an object. Are you in touch with LiDAR companies? Is there perhaps a challenge that you see when it comes to 3D sensing of every single object around the particular arm of the robot?
I guess just a matter of, compared with nowadays, like you can get, like, for example, the Intel RealSense where you're getting 30 frames a second at very low quality, one could argue, compared to what maybe we could get with a laser sensor. I guess in my mind, it's a matter of whether, if we can get it done with a cheaper, faster sensor, that's what we're going to probably choose. So I guess that's the main challenge with the LiDAR. I agree. I hope it's not a matter of 10 euros saving, but I guess in the end, that sort of speed trade-off, can we use the machine learning technology to overcome the cheap sensor? I mean, the LiDAR traditionally for the autonomous driving side, yes, but for the smaller, let's say on the manufacturing side, how do we use that exactly? Where does that come in? I guess is the challenge there for the LiDAR. So currently we are not using that technology, but certainly if we could integrate it somehow into the pipeline to address specific accuracy needs, if we could integrate it, this and that to achieve something, then maybe,
The new iPad has LiDAR. So LiDAR, it was invented actually 20 years ago, 30 actually years ago. So it is not a new technology, it's not a breakthrough. And I do know, Santiago, do you want to comment on the visions of Simon and Ian on the cost reduction and also aspect ratio?
Well, cost reduction, of course, is an issue and needs to be tackled, and the prices are more or less stagnated in a given point. But I guess that there's something that we more or less forget, and it's the management of the point cloud when you create that. So managing the point cloud when you got 3D all around you, and you got all that flux of points, it's not got something which is obvious at all. And then the fact of being able to provide something like a linked 2D and a 3D data is something that gives you a lot of value, because you can play with the best of both worlds. That would be my final comment on that. I mean, it's something which is going to evolve maybe, but I don't think it's going to be something, maybe when they get to automotive with 100 euros, we will speak of other things, but for the moment it's not at that point. And several applications still need LiDAR because 3D, and if you need redundancy, is something that you want to keep and to touch. So,
I'm not a fan of cost reduction roadmaps, because especially in the setting that we want to put LiDAR is about reliability and long-term stability and low maintenance. These three should come before cost, and we could have a beer about this because I really would love that. It's a pity that we work from home. I want to go to the next presentation. PLX is talking about laser tracking, and ABB and Epson were very interested about this, so I want to go there. New York, one of my favorite states in the whole United States and in the world. I want to know what PLX can do for the rest of the community. The floor and the attention of everyone goes to these fantastic three letters, PLX. Malcolm, the floor is yours.
Hi, thank you. So sharing my screen. Hopefully you can all see that.
Crystal clear.
Welcome to Disruptive Laser Metrology and Robotics. My name is Malcolm Humphrey. I'm the new Program Director for Active Optics within PLX. Come on. There we go. So I just briefly wanted to run through who PLX are. Probably a few of you have not heard of us as yet. Bit about MOST technology, the recent acquisition of Reflex Imaging Limited, and the new Active Optics division within PLX. So PLX have been at the forefront of photonics since 1955. They produce high precision optical components using their proprietary manufacturing processes. The invention of the hollow retroreflector back in the 70s was really the path for us for working with top military and mission critical projects. So last year in December, as it happens, saw the acquisition of Reflex Imaging, and that has really allowed us to increase the capability of our products. So for those of you not familiar with our MOST technology, it's our most popular technology at the moment. And this is about integrating multiple optical elements into a single monolithic structure that enables high degrees of stability in harsh environments without any loss of accuracy. So, as I mentioned, in December last year, PLX acquired Reflex Imaging, who were my old startup company. This really started off with Reflex Imaging approaching PLX with regard to the MOST technology, and we wanted to use it for our upcoming OLAM metrology system. We very quickly found that there's a lot of synergies between the companies, and that resulted in the acquisition of Reflex Imaging in December. So this collaboration has already yielded some interesting new technologies, which we'll hopefully talk about in future meetings. Okay. So the new Active Optics division, this is all about active optical devices, mainly based on MEMS devices. So anywhere we need accurate beam steering, scanning, modulation, that's what we're all about. An example of this is the former Reflex Imaging product, the LAM device. So this is a bit of an overview of it here. So we have a diode laser. We've got a circular laser profile. This is deflected onto a MEMS scanning mirror. This in turn deflects the laser and a linear scan pattern. So we have, you see the various paths going out there. When that goes out of the unit via this beam splitter, you hit a retroreflector, we get a pulse of light back to the photosensor down here. So the way this works in practice is you would have the LAM unit in this example scanning a smart target. It's scanning it in a plane because it's a 1D device. Whenever the laser dot hits a retroreflector, we get a pulse of light back. We know the angle of the mirror at the time of the pulse, therefore we know the angle between the lamp and the reflector. We know the geometry of the smart reflector in this case, and so therefore we can work out the range, lateral position, and even using these two inner reflectors, we can work out the vertical position. Now, we did some evaluations for this with the Advanced Manufacturing Research Centre here in the UK in Sheffield. We looked at two potential applications for this. The first was tracking the position of a robot end effector in real time using two lamps and a known geometry. This was scanning in a plane. And this has applications for where your workpiece is relatively planar. So an aircraft fuselage or wing, for example. So where you need this large volume metrology. Another application, we're actually mounting the lamp on a robot end effector, and we're using the robot to actually scan the lamp across a workpiece. In this case, it is a reconfigurable assembly jig. So the robot would place clamps on the assembly jig, pick up the lamp, scan where all the clamps are in relation to itself, and it can then start working on whatever task it needs to do on the assembly jig or the workpiece. So as I mentioned before, we have an upcoming project called the OLAM. So this is where we're taking the single dimension scan device and we're now going to scan in a volume. So this is really following feedback from many of our users as to what they would want to see in the LAM product going forward. So very brief comparison between the upcoming OLAM technology, which stands for orthogonal laser metrology module. I should have mentioned that earlier. Probably the headline figure there is the sample rate of this device. So we can sample anything up to 256 targets with a refresh rate of 500 Hertz on individual targets. And we think that feature alone is pretty unique in the market. All right, photogrammetry systems can do that with conventional cameras, but they're limited by the refresh rate. And more importantly, the latency in processing that image. And as you can see, the latency of our OLAM system is going to be very, very low because we're processing data on the fly and sending it to the host system on the fly. So some of the features of this and benefits, accuracy is probably one of the big ones because we're using our novel technology and MEM scanning mirrors, which are very stable devices anyway. We're seeing very good accuracy for these devices, hardly any drift. We haven't been able to measure any. And the way we see this being used is really to be integrated into a robotic manufacturing cell as a permanent fixture, because these are going to be low enough cost that becomes economically feasible to do that. And that will really reduce downtime by allowing you to eliminate calibration cycles for your robot. So at the moment you might use a high-end laser tracker system to periodically calibrate your robot. Because our accuracy is approaching that of the high-end systems, you no longer need to do that. And of course you're not losing accuracy in between those calibration sessions, so your overall productivity yield goes up. So what we're looking for is really some partners for us for this OLAM project, specifically robotic integrators to help us take the OLAM technology and turn it into an end product or a full system where, that includes all documentation, calibration tools, the systems, the integration into the robotic control systems. These are real-time devices, so we fully anticipate them being able to be used for real-time robot control. And there'll also be opportunities for developing kit parts such as calibration and verification tools. And finally, what we can offer anywhere where you need precision laser beam steering, scanning, manipulation using MEMS devices, that's our expertise. We can, anything that's real-time processing, we can really help you with that. So thank you for listening. we have any questions from the
Thank
floor?
you very much, Malcolm. You can't imagine how many people are texting me that they want to get in touch with you afterwards to talk about this OLAM project. This is really, really great. I want to find many potential collaborations here, and we'll come to them afterwards. But for me, I really always want to see on both sides of the supply chain how to collaborate. But I'm gonna get this out of the blue. Simon from Jabil, when you heard this presentation, what kind of opportunities do you see to integrate this OLAM system into robots?
That was really an interesting talk right here. Thank you, Malcolm, for that.
You're welcome.
To be frank, I need to further understand, since you already also highlighted that the system costs are extremely low, or that's at least what I understood. And that would be a question, is that in a double-digit US dollar range, triple-digit? Can you, let's say, narrow this down a little further?
Sorry, the range of the device, did you?
The cost range. You mentioned that.
Oh, the cost range. Sorry, yeah.
It's let's say feasible to implement this in scale. Where are we approximately?
Absolutely. I mean, it's based on MEMS scanning mirror devices. These are commercial devices. They're pretty low cost. You know, for low volumes, we're talking, you know, probably the cost of a car. You know, a cheap car, as an example. Obviously, would need to, you know, go through the process fully to actually come up with an end cost. But we are aiming for a cost figure that is below photogrammetry systems, well below laser, you know, the high-end Leicas of this world, you know, fraction of the cost of those. We want this to be economically feasible to fit into your, you know, $80,000 robot without driving up the cost of the manufacturing cell. And of course, the higher the volume, the better the cost becomes, because we're looking at the efficiencies of mass production now.
Definitely. Thank you for that. That helps me put this into perspective. And I asked Jose to put us in contact after the meeting.
Malcolm, I really love this slide, and I think it summarizes clearly what the OLAM is. You are trying to scan in volume. Yep. You are trying to approach this is 30 microns accuracy at 5 meters.
That's it.
It is awesome. It is great. Could you maybe share with us like the challenge that you will have for me to find the right company to help you on this? There are many, but you could point out the challenge.
Yeah, I mean, it would be great to, you know, work with perhaps another company that is developing this kind of technology as a partnership. It would be, I mean, one of the criticisms we had when we were reflex imaging is we were selling a what was called a prototype product, if you like. So we didn't have the software to go with it, the integration into the robot control system, all of that, those things that is, you know, essential to creating a system that you can then go and sell to the, you know, the Boeings and Rolls-Royce of, you know, and Fords of these worlds.
We will find you companies are working on that. But first, there's a question in the chat. It's coming from ABB Robotics. Jan, thank you very much for being with us today. What's on your mind?
I was just thinking about the interface, because you mentioned you have higher bandwidth by far compared to other technologies, and how do you transfer it also, and how is communication to the robot control?
So we can basically implement any interface that the user wants. What we have done with the existing LAN products is we're using 100 megabit Ethernet for that with Modbus protocol. And the latency then becomes how well your network is performing rather than the LAN device itself. Internally, we can, you know, output data very quickly within the device. It becomes more about limitations of your network. But as I said, if you've got a CAN bus there, if you've got RS422 or RS485, you know, that we can absolutely interface to that.
I also have a comment question. I also want to give the floor to Philip from CSEM in Switzerland. Philip, thank you very much for joining here. Any comments, suggestions that you can give Malcolm from PLX? This is a clear room for cooperation, in my opinion.
Oh yeah, we collaborated over the last couple of years together with Leica laser tracker. So this is of course then the high-end, much more expensive system. So I think it's very interesting from Malcolm that they go on a high accuracy and rather low cost system. We developed then the full control pipeline, and this is of course a lot of work. So we integrated the Linux real-time system where we achieved the data from Leica over Ethercat with 1 kilohertz. And then you have to do a lot of processing because it makes no sense to give 1 kilohertz to the robot control. So you have to do the right filtering. You have to move then the anti-swing movements. You have to compensate. So, but I think it's really interesting. So I posted the link to the Clarke project. So this is large scale. It's 22 meters by 6 meters, and accuracy is then. We achieved accuracy in the range of 300 micrometers, not 30, so 300, 0.3 millimeters.
Yeah, that's achievable. I mean, I mean, we're aiming for a range of up to 40 meters for a single OLAM unit. We're achieving 20 meters without any optimization today with the existing LAM unit. The accuracy is angular accuracy, so it scales. So 300 microns at what, 30 meters, you said? That's probably within the range, the capability.
Malcolm, Philip, this is really a great room for cooperation. I'm a huge fan of the Kraken project funded by the European Commission, really an amazing European project. So I would like for you to have a look at that website. And thank you for a great presentation, Malcolm.
Thank you.
Christopher from Carter Robotics. So it was so great to have you at the meeting. We heard about so many technologies. I want to finish with a positive message, with something to make us dream. What is going to happen with the world of robots?
Well, if those of us have anything to do with it, it's to have the people not be afraid of what robots can do for humanity, and that there's so much that people can learn about themselves by just reflecting their emotions, their behavior, their dreams, their fears onto that machine, so that it can be communicated in a way that perhaps you hadn't thought of it before.
Christopher, I agree with you from the beginning of your presentation. You are too good to be true. Thank you so much for being in this meeting. And I would like to say that over the last 2 hours, we really talk about 3 key challenges. To talk about the control, accuracy, and speed. I borrowed this from Ian, from Epson. And on the control, the integration of RGB light sources, the integration of different passive and active imaging solutions, working under low light and laser beam tracking. In accuracy, 3D shape preservation and sensor fusion are really the tool. And speed. Fast scanning with the laser was one of them, and actually incorporating on machine learning based hardware to have all these ideas that we have on machine learning really already in the robots. It was really great meeting. All I have to say is that I really can't believe that over 2 hours we talk about so many different topics and we scouted so many cooperations. Francesca keeps saying we only have 5 speakers, 6 minutes each. Are we gonna fill 2 hours? And Francesca said, of course we're gonna fill 2 hours. We could have filled 20 hours. The only pity is that we cannot go for dinner now. Most important, the meeting is not over. If you want to get in touch with any of the participants today, jose.pozo@epic-azoc.com and I will make those introductions. Please always remember that it is all about the follow-up. It's all about the follow-up. Don't just close your laptop and go for dinner now. Make sure that you follow up with the right companies and you find rules for cooperation. Working together is the secret of EPIC. On behalf of an amazing team of technology experts in the medical, in integrated photonics, in the laser, in the optics, the best innovation manager in the world, Antonio Raspa, an amazing team of marketing and event management experts, and our CEO, Carlos Lee, the heart of EPIC. I would like to say thank you for making my dream of photonics in robots become true. This is the agenda of the upcoming online technology meetings for EPIC. If you see any interesting topic, like the one that we have on Meeting Planet on Wednesday or on Monday on CMOS imaging applications, register online as soon as possible. Don't tell me didn't warn you. Until the next time, take care of each other, wash your hands and wear a mask. Be EPIC. Bye-bye.